may handheld portable tools to use.
Good. That is a good. Just proceed.
In construction site, not all the tools that we use can be used there. You need some special tools. So when installing, for example, electricity in the construction building, you should first look for safety first, so that to avoid dangers like electric shock, fire, or even to damage the things around that area. Another hazardous area is in agriculture and horticultural location. In this area, chemicals are applied which can be dangerous to human health. You should, when working on this area, you should look for the best you should wear the best clothes which may protect you from the dangers of the chemicals.
As well as you should also make sure that whatever you are using to install does not have any sparks that can cause maybe fires from the chemicals. Yes, Gasheru?
Yes.
That is a good trial. What Anthony has been taking us through is the types of hazardous areas, or areas that we need to take a lot of care. So people like Edgar, who have just come in today for this lesson, since we started this unit this semester, we have been talking about a special installation, hazardous areas. So the hazardous areas, these are hazardous areas. These are areas that have that are very dangerous areas. These are areas that normally possess a lot of dangers, like explosions are very certain. Places like doing an installation in a petrol station or in a construction site, those are hazardous areas. These are when we talk about hazardous areas, these are dangerous areas. They are areas that are prone to accidents at any time. There are areas that can easily cause harm, that can easily prompt an harm or an accident for the people working there, for either users or even the people working there. So there are areas that need to be taken with a lot of care and a lot of caution. So we have already identified the zones. We talked about zone 0, zone 1, and zone 2, or class 1, class 2, class 3. Those are the area, the classification. And from the video, you saw how those guys were saying that when you want to classify, you have to consider or to inspect and be sure that the amount of danger in this area is at this point. So now, today, the main thing that we're going to do today is about inspection. Remember, we did some inspection when I showed you the IEE regulations. When we were talking about the IEE regulations last time, the regulations gives you a lot of things that needs to be done during installation and inspection of special areas. Now, today we are going to wind up on this topic on installation and reporting. Now that you are an electrical engineer or technician on site or for a certain company, you have been tasked to do an installation in these hazardous areas. Now you need to give a report. We are going to go through steps or some of the things, important things, that are involved in giving a report or inspection and testing of these hazardous areas. And I remember telling you that when we are doing inspection and testing for these hazardous areas, it is the testing itself is always normally done like any other place. It is done like any other installation that we do. The inspection is inspection. It has a standard inspection, and that is why we last week we talked about what are the basic inspections that are normally done. We talked about the earth loop impedance test inspection. We talked about the polarity test. We talked about the insulation test. And which is the last one that we talked about? Somebody remind me. They are the four main tests. That is the earth loop impedance, the insulation test, the polarity test. Somebody give me the last one. Somebody who remembers the last test that we said about?
Continuity of protective conductor.
Good. That is there. Those are the four main tests. And one important thing, and the reason why we are doing these things is the moment you guys graduate or finish your certificate, and now you'll be moving to diploma, you can go to the ERC. We call it the Energy Regulatory Commission. These days it is called IPRA, the Energy and Petroleum and Renewable Energy Commission. It is used for regulating electricians, and they do the certification. So the moment you achieve that certificate, you go there, and the first question that will be asked is about the inspection, the installation inspection test. What are the major tests that are done on site? How do we do it? You remember I gave you a video of how we can do all these things. How the loop impedance test is done, how the insulation test is done. We did about that. We even looked at the IE regulation on this test, how the polarity test is done. Those are the things that you have to explain. And before you are given that certificate or before you are certified, they give you an exam. And these are the things that they are going to ask there. So you'll start with a C2 exam. And a C2 exam, the moment you are given that certificate, that it means that you have been given the powers to do all the electrical installations that are done in single phase. All the single phase installations you can do, and you can do a story up to four story. A story house of up to 4 story. You cannot do 3 phase, but you can do single phase, and that is very good. So the moment you have that certificate, you can work anywhere. You can even open a company using that certificate. So it is a very important unit for us to do. For a loop or a gap for you people to venture in. So the moment you finish, and even before you finish, plan to do that. The moment you get your certificate, apply for those licensing, and then you can be able to work anywhere, and you can even start your companies to start your businesses. So those are some of the advantages why you learn this thing. So today I'm going to take you through the electrical installation reporting conditions. Installation condition reporting, that is the classification codes for domestic and similar electrical installation. I said installation reporting, that is for inspection and testing, is normally general, but we are going to look at now this special installation. So we start. Everyday electrical installation deteriorates with the use and time. Therefore, if the safety of the users is not to be put at risk, so it is important that every installation is periodically inspected and tested by competent persons. And who are these competent persons who can test? These are the licensed persons. We normally have people who are licensed to do that. So before you are licensed, you cannot do such tests. Then the BS7671, that is the code, as it was the amendment, said that every electrical installation is subject to periodic inspection and testing. So the inspection and testing should be carried out in appropriate intervals in order to determine what, or if in case anything needs to be done to maintain the installation in a safe and serviceable condition. So the result of the inspection and testing need to be clearly detailed in a report. So any observed damage, deterioration, a defect, dangerous condition, and non-compliance with the requirements of the current edition, that is that code, that may give rise to danger should be recorded and appropriately classified for remedial action. So it should be done in mind. It should be borne in mind that, as stated in the introduction of this code, and the code is up there. Let me read the code. The aim of the guide is to provide practical guidance of competent persons to use the classification codes that need to be attributed in each observation recorded during the periodic inspection and testing of an electrical installation for the benefit of the person ordering the report. So the guidance it says that is limited that the range observation that are likely to be associated with domestic and similar electrical installation. So it takes to account the publication amendment of this, which means that it has to be taken into much consideration. So the results of inspection and testing need to be clearly detailed in a report. Any observation, damage, deterioration, defect, dangerous condition, and compliance with the requirements of the edition may give rise to danger should be recorded and appropriately classified for remedial action. So it should be borne in mind, we have already said that as stated in the introduction code, that existing installation that have been constructed in accordance to earlier editions of the standards may not comply with the current edition in every respect, but does not necessarily mean that they are unsafe for continued or as required upgrading. So normally these codes are normally upgraded and they move they normally change just slightly depending on the evolvement of the technology. So an electrical installation condition report, as its titles indicate, a report that, and not a certificate. It provides an assessment of in-service condition of an electrical installation against the requirements of the edition of current at the time of the inspection, irrespective of the age of the installation. So the report is primarily for the benefit of the person ordering the work and the persons subsequently involved in addition of remedial work for further inspection. So the report may be required for one or more of a variety of reasons. So for which many impose particular requirements or limitations to inspection and testing. So the report is required to include details of the extent of installation and of all limitation of inspection and testing. So including the limitations and inspection, including the reasons of why the limitations of the name of the person who does the inspection. So in short, to explain what these people are saying is that anytime that an installation is done or an inspection is done, it normally has to have a report. So you'll find yourself 1 or 2 times on site. So whenever you do an installation, there's normally a report. This report goes in hand with the as-built drawing. The as-built drawing, these are the drawings that show what is already installed or what has already been done. So when we give out this report, normally it is attached with the name and the signature of the electrician or the electrical engineer who has done the report and the inspection, so that in case of any fault or in case of anything that happens, they know who to trace, they know who to ask what happened and what process they had done. So the report provides a formal declaration that within the agreed and stated limitations, the details recorded, including the observation and recommendation and the complied schedule of the inspection and test results, give an accurate assessment of the condition of the electrical installation at the time it was inspected. So the purpose of periodic inspection. So why do you think we do this periodic inspection and testing? So the main purpose of periodic inspection and testing is to detect so far as they're reasonably practical and if report on any factors impairing or likely to impair the safety of electrical installation. So the aspects to be covered include all of the following. Number one, the safety of persons against the effect of electric shock or burns. Another one is the protection against damage or property by fire or heat arising from the installation defect. Or another thing is confirmation that the installation is not damaged and deteriorated so as to impair safety. Another thing is identification of compliance with the current edition of the code of installation defect, which may give rise to danger. So that is why we inspect. So electrical installation in poor condition present a risk for fire and as well as electrical shock. So electrical inspection is a very important aspect in any electrical engineering installation or any installation that may take place. So we go to the next slide. The inspector, what are some of the things? All persons carrying out the inspection and testing of electrical installation must be competent to do so. They must have the skills, meaning to be competent to undertake the periodic inspection testing of an existing installation. Person must have as a minimum of have a sufficient knowledge of experience of electrical installation matters to avoid injury to themselves and others. Another one is be familiar with and understand the requirement of the current edition code, including those relating inspection, testing, and reporting. Another thing is the person has to be skilled in the safe application of the appropriate test instrument and procedures. Another point is have a sound knowledge of the particular type of installation to be inspected and tested. Like for example, any person doing inspection, especially even for the hazardous areas, they have to have the knowledge and have an idea and all the codes of conduct that are attached to that type of installation. They also have to have sufficient information about the function and construction of the installation to allow them to proceed in safety. So it is very important, and that is why our regulator normally comes in to make sure that the person that is given the license or is certified to do the inspection is a person that has the skills and knowledge. So there are exams that are being done. Normally the theory exams are there and the oral exams and even the practical exam for you guys to be able to show how you can use the instruments. So if the inspector is competent and takes all the necessary safety precautions, including the following correct procedures, now the process of inspecting and testing should not create danger to persons or cause damage to property. So past events indicate that persons undertaking electrical installation condition reporting need to have extensive knowledge and experience of electrical installation matters to enable them to safely and accurately assess the condition of an existing electrical installation. This is especially so when they do not have access to the design and maintenance of the information relating to the installation. So the guidance of isolation procedure is available in another best practical guide. You'll see it. Then the published electrical safety first, which can be downloaded for free. You can even get it from the online. Now the periodic testing and the periodic inspection and testing procedure. These are some of the procedures. The procedure of periodic inspection and testing differ in some respect with those of the initial verification of the new installation work. Now, when you've done new installation work, it is different from the periodic testing. Last week, we were talking about a new installation work. When you've already installed it, the newly installed work, the inspection and testing there are normally different from the periodic testing. So meaning the periodic testing have maybe it's different by using the following. Now, this is because the subject of electrical installation condition report is usually an installation which has been energized and in use of some time. So particular attention therefore needs to be given during the inspection process of assessing the condition of the installation in respect of number 1, the safety, 2, the wear and tear, 3, the corrosion, 4, the damage and deterioration, 4, the excessive loading, the age, the external influences, sustainability, and taking account of the change in use of the building extension. So you can see the types of this. Now, like for example, when you are testing the workability of you can look at this socket. Now it is a potentially overloaded circuit outlet. You can see how many outlets are there. So this is an overloaded socket outlet that can cause a risk to maybe an electrical shock or even an explosion. So also, for reasons beyond the inspector's control, the inspector may be unable to gain access to parts of the existing installation. For example, it is usually practicable to inspect cables that have been concealed within the fabric of the building. So such restrictions are likely to result in the inspection and testing of these parts of installation being limited, so and being omitted entirely from the process. So where during the course of inspection or testing, a real or immediate danger is found to be present in an installation from the accessible exposed live part, for example, the immediate action will be necessary to make it safe before continuing. So, however, discovery of the dangerous condition should still be recorded in the report and classified accordingly. So, the inspector should note that even in domestic premises, the Health and Safety Work Act, the Electricity at Work regulation, effectively require them to endeavor to make safe before leaving the site and with agreement of the user or the owner. Any dangerous condition found on an installation, for example, where there are accessible live parts due to the blanks missing from the consumer unit, suitable temporary barriers should be provided to protect the persons from direct contact with those live parts. So as persons using the installation are at risk, it is not sufficient simply to draw attention of the danger when submitting electrical installation condition report. At this very least, the inspector must ensure that the client is made aware. You have to make the client aware that there is danger there, and at the time of discovery, the danger that exists, an agreement should be made with the client as to the appropriate action to be taken to remove the source of danger. For example, by switching off and isolating the affected part of the installation until a remedy is done or before continuing the inspection or testing. So those are some of the important things that have to be done. Now look at this installation when you are doing inspection. Now this is a periodic inspection. Somebody has already done an extension and you can see the danger that lies here. So this is a danger condition line conductor, condition of the metallic enclosure of the lighting fitting, and in addition to exposed conductors. You can see now this wiring here. Everything is exposed there. Let me zoom out so that you can see. Everything is exposed there, and already there's even a likelihood of a short circuiting there and an explosion. So such connections are very dangerous and risky. So when you identify as an inspector, you identify such an installation, you alert the client or the owner that there is a danger here that can lead to an explosion, and they can do away. You can tell them how they can do away with that. So some certification, registration, and membership bodies make available dangerous condition notification forms. These assist inspection to record and that to communicate immediately to the person responsible for the safety and installation in dangerous condition discovered. Oh, Anthony, you are asking what is the name of that thing. This is just a connector. This thing that is connected is called a connector, and the connectors are normally of different sizes depending on the power that it can carry. We normally have like the 6 ampere, the 30 amperes, the 32 amperes, the 62 amperes, and all that. Or another question? Edgar, you are not seeing anything. Why? Can people confirm? Are you seeing now, Edgar?
I'm not seeing anything.
Why? What about now? I've reduced it. Can you see?
No, the screen is just blank. Haionyeshi any video.
Your screen?
Yeah.
Can you log out and log in again? I rather sing. Gajeru, can you confirm if you guys are seeing?
Yes, mi niko sawa, naona.
Edgar, if you cannot see, log out and log in again. So, Anthony.
Yes.
Did you hear the name of that thing that I said? It is called a connector.
Yes.
You were asking about the white thing.
Yes, the white thing.
Yeah. It is called a connector and normally has very different ranges. Now, Edgar, can you now see?
Yeah, I can see.
Yes, sometimes when you experience such problems, it is a system problem. So you just log out and log in again, you will see it again. So I hope now we are okay, we can proceed. So observations. When we are doing inspections, these are the observations that you can see. We mute our mics again so that we can proceed. So the periodic inspection and testing procedures should identify any damage, deterioration, defects, and conditions within the installation and give rise to potential rise in danger. So the procedures should also identify the deficiencies for which a remedial action would contribute to significant improvement of the safety of the electrical installation. So you have to put all the observations before you give a report. All the observations, like now, for example, the picture that I showed you last is, you have to say that you can even take pictures to show that these are the things that I saw. So you have to record all the observations before you can recommend or make a report on that. So after the consideration, each such observation safety issue should be recorded at the appropriate point in the inspection or test result schedule and further detailed in the observation section and the report. So the observation should be based on the requirements of the edition of that code that we had already talked about. So the current at the time of inspection, not on the requirements of the earlier edition current at the time of inspection. Sorry for that zooming. So each observation should be written in a clear, accurate, and concise manner that is likely to be understood by the person under the work, undergoing the work. So technical terms should be avoided to explain unless it is known that the recipient of the electrical engineer or electrician, for example. So when you are dealing with your clients, you should avoid technical terms that the client might not understand, or unless you know that you are dealing with somebody who has an electrical knowledge, then you can use the technical terms. So an electrical installation condition report is intended to be a factual report on the condition of an electrical installation, so not a proposal of remedial work. Therefore, each recorded observation should be described a specific deficit, omission, or item for which improvement is recommended. So the observation should detail what the situation is and not what is considered necessary to put in right. For example, excessive damage to the consumer unit enclosure would be appropriate, whereas the consumer unit be replaced would not be there. Now, only observations that, let me zoom out so that you can see what I'm reading. Only observations that are supported by one or more regulations in the edition current at the time of the periodic inspection should be recorded. So the particular regulation numbers need to be entered in the report unless specification required by the client. So but should Xavier be reminded the inspection that it is only compliance by that code that is to be considered. Observation based solely on personal preference or custom and practical should not be included. So when you are doing this observation, maybe there's something that maybe an installation that is done, and maybe you are seeing something that you normally don't like yourself. Don't always put it as a record. You only put a record what is according to the code of installation code that is normally put down. That is the standard code. So now, like for example, this is an installation above the bad zone, that is outside the zones. You can see the zones there, the hazardous zones or dangerous areas in an installation. And we said that a bath area, like a bathroom, is a dangerous area because a leakage of electrical leakage and electrical shock are normally potential dangers that are attached to them. So the classification codes, as we had talked about them, and now how we can do periodic inspection about them. Now, each observation relates to a concern about the safety of the installation should be attributed to the appropriate classification code selected from the standard codes, that is the code 1, code 2, and code 3. And then each code has a particular meaning. And we say that code 1, that is 1, danger is present, that is the risk or injury, immediate remedial action is required. This code 1 is a very dangerous area, and immediate remedial or corrective measures should take place. And when we go to code 2, it means that there's a potential danger. And it's not that urgent, but it needs to be looked at. And in code 3, it means that improvement should be done. Improvement is recommended. So only one of the standard code classification code should be attributed to each observation. So if more than one classification code should be attributed to one observation, only the most serious one should be used, like code 1 being the most serious. So where the inspection and testing, and remember we talked about the code 1 and code 2 and code 3. So when you realize that this area, there is a danger in this code 1, it is something that is spontaneous and can cause a destruction of a whole building. So you need to act immediately without even giving any chance. So where the inspection and testing procedures identify an item which is dangerous for potential or potentially dangerous, it should be identified in the inspection or test results schedule for the report by attributing to a classification code C1 and or C2 as appropriate in the outcome column of inspection schedule, or where provided the remarks column of the test schedule. So where the inspection and testing procedures identify an item which is not dangerous or potentially dangerous, but for which improvement is recommended. So it should be identified in the inspection or test results schedule of a report by attributing to it a classification code C3 in the outcome. The column of the inspection schedule or were provided the remarks column of the test schedule. So where during inspection and testing a real and immediate danger is observed that puts the safety of those using the installation at risk, so classification code C1, that is danger present, must be given. Where classification code C1 is considered appropriate, the client is to be advised immediately and also in writing that immediate remedial action is required. So as that is meaning has been taken. So to remove the danger, you have to remove the danger immediately. As previously indicated, this action is necessary to satisfy the duties imposed on the inspector and other duty holders of the health and safety and at work. So you can see now, like the live parts exposed and touched. You can now see, like now you are doing an inspection and you identify such things. So you classify this one as class C1 because it is very dangerous, because it has a potential instant explosion. So like this one, you can see the cable's insulation has already been worn out. So in case of anything, or maybe something pushes this thing, there is a possibility of the two wires shorting and an explosion or a fire occurring in that place. So this one, you recommend that it has to be immediate and has to be removed immediately to avoid any harm. So in general terms, the classification code should be used as follows. So now let us look at them. So C1, that is code C1, that is danger is present. This code should be used to indicate that danger exists, requiring immediate remedial action. We have already said. So when you classify a place as a class C1, it means the danger in that place is instantaneous and it can be very dangerous. So the person using the installation are at immediate risk. So the person ordering the report should be advised to take action without delay to remedy. So the observation deficiency of the installation or to take appropriate action. So such as switching off or isolating the affected parts of installation to remove the danger. So some of the immediate actions are like isolating that part so that you can remove the danger, or even so that you can cut power away to avoid any danger. So the inspector should not wait for the full report to be issued before giving this advice. So as previously indicated, bodies make an available dangerous condition notification forms to enable inspections to record and then to communicate immediately to the persons ordering the report. So any dangerous conditions are discovered. So we go to C2. When you code an area C2, C2 is the potentially dangerous. So this code should be used to indicate that whilst an observation deficiency is not considered to be dangerous at the time of the periodic inspection, it would become a real and immediate danger if a fault or other foreseeable event was to occur in the installation of the connected equipment. So the person ordering the report should be advised that whilst the safety of those using the installation may not be at immediate risk, then the remedial action should be taken as a matter of urgency to remove the source of the potential danger. I think that one is self-explanatory there. Then we go to code 3. When you give a report and setting it as code 3, in code 3 we say that the code should be used to indicate that whilst an observation deficiency is not considered to be a source of immediate or potential danger, then improvement would contribute to a significant enhancement of the safety of the electrical installation. So those are the codes, and that is the ladder and in which they are used. So further investigation. The model forms of this code incorporating Amendment 1 provide for a need of further investigation to be indicated against each inspection and test outcome. So, and against each observation. Usually, and however, it should be possible to attribute a classification code of each observation without a need for further investigation. So the purpose of the periodic inspection, sorry for the zooming. The purpose of periodic inspection, as previously stated, is not to carry out a fault-finding exercise. And normally electricians fall culprits of this because you normally need that work. You have done inspection, so you sometimes tell the client that this one is dangerous, I need to change. It is not a fault-finding, but it is to assess the report on the condition of the installation within the agreed extent and limitation of the inspection. Therefore, where an observation can be attributed to classification code, further investigation should not be required for the purpose of completing the report. So further investigation should be called for in the respect of observation unless that investigation could reasonably be expected to reveal danger or potential danger. So further investigation should not be called for simply because it would be nice to know. For example, why a socket outlet is unearthed. Sometimes you realize that a socket outlet is not earthed. So that is a foreseeable danger. That is code C3. So when you say that you give further inspection to know why or why it was omitted in the first case. So if an observation cannot be attributed in a classification code due to reasonable doubt as to whether the danger or potential danger exists, so the outcome of the assessment must be reported to be unsatisfactory. So the person ordering the report should be advised that the inspection and or the testing has revealed a potential safety issue which could not, due to agreed extent or limitations of inspection, be fully determined, and that the issue should be investigated as soon as possible. So, for example, of an observation that might possibly justify further investigation is given in the page that follows. So, departure from the requirement of the current edition, that is the code that we have been talking about, that could not give rise to danger in need of improvement. The Amendment 1 of this code no longer requires departures from the requirement of the current edition. So summary of the conditions of installation. We are doing a summary now. The summary could adequately describe the general condition of installation in terms of electrical safety. So taking into account of the specific observation made, it is essential to provide a clear summary of the condition of the installation, having considered the following. Number one, adequacy of the earthing and bonding arrangement. So after doing the inspection, you have to make sure that the earthing and bonding arrangements are adequately made, meaning the earthing is correctly installed. And two is the suitability of the consumer unit and other control equipment. You make sure that the consumer unit is properly installed, and all the control equipments like the circuit breakers and the main switch are properly installed and they are working properly. And also inspect that the types of wiring systems are and its condition. Make sure that the conditions of the wiring system are accurate and correctly. And then another thing is that the serviceability of the equipment, including the accessories. And then another thing is the presence of adequate identification and notification. Then the extent of any wear and tear damage or other deterioration. Then changes in the use of premises have led to or might lead to deficiencies in the installation. And then another thing is minimal description, such as poor superficial statements such as recommended a rewire are considered unacceptable as they do not indicate the true condition of the installation. So you don't just say that it is poor. So what is poor? You have to say the exact thing that you found. You report exactly as you found it. So it would often be necessary or appropriate to explain the implications of an electrical installation condition report in a covering a letter of the benefit of the recipients who require additional advice and guidance about their installation. So, for example, where an installation has deteriorated or been damaged so as an extent that is unsafe, serviceable life can reasonably be considered to be at an end, or a recommendation for renewal should be made in a covering letter, giving an adequate supporting reason. Reference to the covering letter. So those are just a summary of what is needed. So you can now look at example. You can look at this example like unsatisfactory connection of a downlighter. Now look at this one. It is not even up to standard and it's not adequate. It can even lead to a short. It's not very presentable, so it is unsatisfactory. So you can give a recommendation like it is an unsatisfactory condition of that. So it is the client to either choose if a rewiring is needed, but not you to recommend that now this one is needed. So on the model of electrical installation condition report given, a box is provided for the overall assessment of the condition of the installation to be given. So after due consideration, the overall condition of the installation should be given as either satisfactory or unsatisfactory. So if any observation in the report has been given as code C or code 2, code C1 or code C2 classification as the categorized in this guide, or if any observation require further investigation to determine whether the danger or potential danger exists, the overall assessment of the condition of the installation must be reported to be unsatisfactory. So if there are no observations in the report classified as C1 or C2 or any required further investigation, it would be a reasonable report to overall condition of the installation as unsatisfactory. So the recommended interval until the next inspection should be made conditional upon all the observations that have been given. So classification code 1, danger present, being remedied immediately, and all observations that have been given according to potential dangerous or any or that require further investigation being remedied as investigated respectively as a matter of urgency. So where the space provided for the description of the general condition of the installation is adequate for the purpose and it's necessary to continue the description of the additional pages. So examples now of the codes, we have the examples there. And now before I go to the examples of the classification codes and the types of dangers that can be found, I want now people to unmute their mics and tell me something up to that point, what you've gotten. Unmute your mics. Yes, Edgar, say something.
Yeah, we have gone through the classification codes. Yeah, like C1 presents the danger present, C2 potentially dangerous, C3 improvement recommendation. Then the the points to consider when summarizing. There is, you make sure there's adequacy of the earthing, suitability of the CCU and other control equipments, then type of wiring system, the serviceability of equipments, presence of adequate identification and notices.
Good. So those are some of the important things. Yes, proceed.
Then we've said when writing, when giving the final condition, you either say it is satisfactory or unsatisfactory.
You avoid saying what?
Poor.
We avoid saying poor, or we avoid saying rewire, because when you say poor or rewire, it means that it's like you are looking for some job for yourself and it's not professional.
Yeah.
Okay, now let's proceed. Now we are going now to examples. You want to see these typical examples of when these problems are occurring. Now, for example, Wainaina, you went away. Eh?
Yeah?
Ulikuwa umepotea?
Sijui nini ilifanya ikapotea, ndo sasa nimerudi.
Sawa sawa. Sasa tumeingia kwa examples. So mute your mics again. We are looking at the examples of the use of codes of classification. So I'm zooming so that you guys can read with me. It is entirely a matter of competent person conducting the inspection to decide on the classification code to be attributed to an observation. So the inspector's own judgment as competent person should not be unduly influenced by the person ordering the work. So the person signing the report are fully responsible for its content and accuracy. So the following are examples of an exhaustive or reference the RCD. And we said RCD are the residual circuit devices or breakers that are used for protection on hazardous areas installations. Like for example, machines that are working outside the house or buildings, we use circuit breakers like the residual circuit breakers to protect them from overcurrent. So they mean additional protection by an RCD have a rated operating tripping current not greater than 30 milliamperes and an operating time not exceeding 40 milliamperes at the residual time. So the code one dangerous present. So the observation that would almost certainly warrant a code C1 classification include exposed live parts, and that when we have exposed live parts that are accessible to touch, such as where we have a fuse carrier. Now you can see now like this one, a fuse carrier or a circuit breaker is missing from the consumer unit and a blanking piece is not fitted in its place, like termination of the connections have no or damaged barriers or enclosures. Live conductors have no or damage, they are damaged on installation, or an accessory is badly damaged. Now, like for example, we have a socket outlet with a broken face plate. Now you can see this example of socket. It might be well installed, but because of the broken faceplate, it can allow even water to get in, and it can allow water to get in. And the moment the water gets in, it can place a danger or a risk to the users of that place. So this one can be classified as code C1. And then we proceed and say now now it also as conductive parts have become live and result to fault, like the previous picture that we had seen. And then we have incorrect polarity. Sometimes the polarity is not correct. So code C2. Code C2 observation that would usually warrant a code C2 classification include absence of reliable or effective means of earthing for installation. Now, like absence of reliable means, now look at now this one. Look at this type of installation. It is a very poor part of installation. Like now, the public utility like water pump being used as a means of earthing for the installation, it can be very dangerous. A gas or oil pump being used as a means of earthing for insulation. A cross-sectional area of earthing conductor does not satisfy adiabatic requirements, and that is does not comply with the regulation. Absence of circuit protective conductor for a lighting circuit supply. One or more items of the class A equipment are connected to switches having metallic faceplates. That is another problem. Absence of a notice warning that lighting circuits have no circuit protective conductor. Another thing is absence of a circuit protective conductor for a circuit other than the lighting circuit supplying one or more items for class A equipments. And then another thing is absence of earthing as a circuit outlet, absence of the main protective bonding. Another issue is inadequate cross-section area of the main protective bonding conductor where the conductor is less than 6 millimeters square or where there is evidence of the thermal damage. Another thing is absence of supplementary bonding where required, such as in isolation or containing a location containing a bath or shower where any of the following three conditions are not satisfied. Now the conditions are all the final circuits of the location comply with the requirements of the regulations for automatic disconnection. All normally these hazardous zones must have a requirement or a provision for automatic disconnection when there is a fault, and then all final circuits of the location have adequate protection by means of that 30 amperes, that is the RCD, and then all the extraneous conductive parts of the location are effectively connected to the protective equipotential bonding, that is the main earthing terminal. We talked about the equipotential bonding. Equipotential bonding is all about bonding. Bonding means connecting all the metallic insulations or all the metallic parts in the house, connecting them to the main earthing, that is the equipotential bonding, making sure that they are correct. Another one is the main RCD, that is the residual circuit device or voltage operated earth leakage circuit breaker on the TT system, that is the TT earthing system, fails to operate when test with the instrument or the integral test button. And before I read this next point, I've just seen this thing and I want to ask, maybe unmute your mic so that you respond to this. With your teacher the previous semester, those who were there last semester, did you learn about the types of earthing or the types of earthing systems with your teacher, with Mr. Joseph? Anthony?
Yes. Yes.
Or you learned about them, so you know about the TT system of earthing.
We learned about in module 1.
Module 1.
Oh, not module 2?
Yeah.
Yes.
Good. So you guys, when we talk about the TT system, I know you are aware, so that is good. So we proceed, mute your mics again. And then we also know look at the absence of the RCD protection for portable or mobile equipment that are reasonably be exposed to use or to be used by outdoors. And then another is absence of the RCD protection for socket outlets in a location containing a bath shower other than the SELV or the shaver socket outlet. Another one is socket outlets other than the SELV or the shower socket outlets located less than 3 meters horizontally from the boundary of the zone 1 in a location containing a bath shower. And you remember that a bath shower is a zone 1 at the ZADA's area, and the sockets should normally be located 3 meters horizontally away. That is 3 meters away from the zone, so that to avoid getting splashes of water from the bath shower. Absence of fault protection, that is protection against indirect contact of the RCD where required, such as for socket outlet circuit in an insulation forming part of the TT system. So the circuits with ineffective overcurrent protection due to, for example, to oversized fuse wire in rewirable fuses. Protective device installed in a neutral conductor only separate protective device in the line of the neutral conductors, for example, double pole fusing. Other examples, the earth fault loop impedance value greater than the required for operation of the protective device within the time prescribed in the version, wiring requirements current at the time of installation. Also, we have to look at if we have we are using a ring final circuit having a discontinuous conductor, ring final circuit, or the cross-sectional connection with another circuit, an inconsistent resistance value for the conductors of the ring final circuits. You remember we said that normally after installation we do these tests for the resistance test, and we do unsatisfactory electrical connections such as a loose connection or type of number or a number of size conductors unsuitable for the means of connection. Now look at another one, that is unsatisfactory electrical connections. Let me zoom out so that you look at how it is done. Now look at this. Look at that one. It is unsatisfactory. You can even see the way it is being looped to this side. Now you cannot even tell which cable is going to where and which one is installed where. This is very bad, and it is an hazardous area. So a borrowed neutral, for example, where a single final circuit neutral is shared by two final circuits, such as an upstairs lighting circuit and a separately protected downstairs lighting circuit. So it is also hazardous. So installation resistance for less than 1 mega ohm between the live conductors connected together with the earth when measured with a consumer and a unit with all final circuits connected. Then insulation of live conductors deteriorated to such an extent that the insulation material readily breaks away from the conductors. Another one is scrambling of the of that insulation. Now look at this one. Maybe what happened here is when the pulling of the cables was being done, there was a pulling or there was a peeling of the insulation, and this one can easily lead to a short circuiting or even a fire. Because the moment the live and the neutral meet, there's always a short circuit. So we need to take a lot of care, and when inspecting, this one have to be recorded. So sheath of the insulation and the sheathed non-armored cable not taken inside the enclosure of an unnecessary, such as the socket outlet or the lighting switch, where the unsheathed cores are accessible to touch and or likely to come into contact with the metal work. So note that the code 3 would apply if the unsheathed cores are not accessible to touch or likely to come into contact with the metalwork. Now, for example, this one can be classified as code 3 because it is not likely to be touched because this thing is already in a holder. But in case of anything, or in case of a pulling or an inspection, this one can easily be a potential risk. So that is why it's called a potential risk. Now, cable sheathed not taken inside the metallic enclosure. Now you can see like this one, it is code 3 because it is yes, the wiring is okay, but the moment it is exposed, it can it can sometimes be come out or the insulation can be tampered with time and then cause a risk to and the installation. So an enclosed electrical condition such as the luminaries, such as a defect, can contribute to a fire, probably where extra low voltage filament lamps are used. So fire risk from incorrectly installed electrical equipment, including incorrectly selected or installed down lighters. Sorry, I wanted slide 15. Now, another things are there. Now, fire risk from lamps and exceeding the maximum rating wattage of the luminaries or placed too close to the combustible materials. Evidence of excessive fire, such as charging from electrical equipment causing damage of the installation or its surroundings, and successful functional operation of equipment where these might result in danger. Now, another is immersion heater, like this one, that does not comply with that code, that does not have a built-in cutout that will operate if stored water temperature reaches 98 degrees Celsius, if the thermostat fails and the cold water storage tank is plastic. Now, other immersion heater without a thermal cutout, that is the electro equipment having an inadequate degree of ingress protection rating for the external influences likely to occur in the location if this result in a potential danger. So absence of the warning notices indicating the presence of an alternative or a secondary source of the electricity, such as the standby generator. A fixed equipment does not have a means of switching off for mechanical maintenance, where such maintenance involves a risk of burns or injury from mechanical movement. Now, code 3, examples of code 3 improvement recommendation. Now, observations that could usually warrant the code 3 classification code include the absence of the RCD protection of the socket outlet that is likely to supply portable or mobile equipment to use outdoor, or does not serve a location containing a bath shower, and the use of which otherwise not considered by the inspection of the result of potential danger. You can see them there. Now, at the RCD protection circuit test quality, and now absence of the RCD. Now, sometimes the RCD are not there. Protection for cables installed at a deep less than 50 millimeters from the surface of the wall or partition where the cables do not incorporate with the earth metallic covering, are not enclosed in earth metallic wall work, or are not mechanically protected against the penetration by the nails and the like. So absence of the RCD protection of the circuit of the location containing a bath or shower where satisfactory supplementary bonding is present. Examples of we are still in code 3. A reliance of the voltage operated earth leakage circuit breaker. You can now see that. Now that is a 6 ampere voltage operated earth leakage circuit breaker, courtesy of that lighting. Now, for a fault protection against the indirect contact, now you can see the cables are still there and they are not even covered. So there is a problem there. Absence of the quarterly test notice of any RCD or voltage operated by the earth leakage circuit breaker. Absence of the circuit protective conductor in the circuit having only class 2 of the insulated luminaries of the software. Absence of safety electrical condition do not. We need to have unmarked bonding conductor. We need to be marked that this is a bonding conductor. The marking, absence of the marking can also pose a risk. The sheet of the insulation insulate sheet armor cable not taken into enclosure, and such as sockets, outlet, or lighting switch. You can see there. You can see another example that is there. Cable sheathed not taken inside the conducting enclosure. You can see it there. That is, they are not inside a pipe. Electrical bare protective conductor of the insulated and sheathed cable not sleeved into insulation color code to indicate their function. Now, another one is electrical equipment having an inadequate degree of ingress potential rating for the external influences likely to occur in the location. So if this does not result in the potential danger, now another one is the socket outlet mounted in such a position as to result in the potential damage of the socket or plug. Another thing is the absence of the notice indicating that the insulation has wiring colors to two versions. Another one is absence of circuit identification details. Those are the class C3. Now, further investigation required. Observation that would usually require further investigation include characteristics of electric supply, such as voltage and external earthing fault loop impedance does not comply with the supply industry forms. Now we have others like now the absence of the reliable earth conditions to resist metallic box. You can see there now on earthing, connecting the earthing terminal of the accessory box, and the box does not have a fixed lag and comes into contact with the earthed eyelet of the accessory. Inadequate cross-sectional area of the main protective bonding conductor provided by the conductor as at least, and there is no evidence of the thermal damage. Absence of the supplementary bonding for the installed class 2 equipment where required. You can see there now the main bonding connector not made before the branch pipe. You can see there. Now we can have the branch pipe is there. You can see it's even there and it is into the wall, which is not correct. And then main protective bonding, gas, water, or other surface pipe is inaccessible for inspection. When it is not accessible, meaning it is inside the wall, which is not correct. And then protective conductor overlighting circuit, not incorrect, terminated to the final circuit connecting to class 2. Switch lines are inadequate as the line conductor terminates. For example, a conductor having blue insulation in non-sleeved brown on switches. Circuit protective conductors for final circuit connectors in a consumer. You can see all those there. Term items that are not departures from the current edition. Now we have the following are items that are commonly included in electrical installation condition reports and are requiring remedial action but are not departures from the current edition. Now we have the absence of earthing, or you can even say that there is absence of earthing or bonding. Those are the terms that we can use for metallic sinks and baths. We can also use the renewable fuses where they provided adequate circuit protection. You can also say that use circuit breaker this. You can also say absence of barriers inside a consumer unit. Those are some of the terms that we can use. We can also say that there is absence of bonding connections on boiler pipework where the pipework is not extraneous or conductive. We can also say that the shower supply unit installed in the zone 2 of the location containing the bath shower and the location directly of the shower is unlikely. And then we can say that the absence of switches on socket outlets, fused connection units, or any other observation not directly related to the electrical safety, and hence to the sustainability of the installation on surface. And that is now we can see a consumer. You can see the consumer unit is the circuit breaker on fuses. You can see it. And now like this one does not have the covering, which is not correct. Other issues now for the cautions are the following are items that are worth for appropriate not electro installation condition report, but should not be classified in any given classified code. Now there is absence of fire detection and alarm system, smoke, the absence of emergency lighting system in a location normally required as the system, for example, the communal area of the block, combustible materials stored in a close proximity of the electrical intake equipment, all those. And then we are done with the presentation. And now I want people to unmute and say something. Unmute and say something. Yes, Edgar, you are the first one. Mute. Say something up to that presentation. Up to that point.
We have talked about the examples of the live classification of codes. Like some points for the code 1. Yeah, exposed live parts that are accessible to touch, i.e. like fuse carrier, circuit breaker missing. Yeah. Conductive parts have become live. Kama ile socket imetoboka mahali, maji inaweza ingia na ikakos nini danger. Pia kuna incorrect polarity. Then for code number 2, yeah, just some few points like absence of proper earthing at sockets outlet, absence of main protective bonding. Pia kuna absence of protective conductors. Yeah, for code
So
number
at least number 2.
for code number 3,
Yeah.
Madam wacho mwingine aseme.
Sawa, Gasheru msaidie.
For code number 3, first, that code means that improvement of the installation should be done, and the examples of this code is absence of circuit protective conductors, sheath is not in an enclosure, and absence of identification details.
Are you done? Okay, let us hold it there. And there's something that I wanted us. This is another slide, but we have already talked about the codes. We have talked code 1, code 2, code 3 of now the inspection when you are doing inspection. But now the thing that we didn't do is now the process. How do we carry out the inspection process? I want us to go through the process, and I think it is the last thing that I'll be presenting before we can finish the work today. So when we go through the process, we can see there is the inspection process. In a new installation, inspection should be carried out progressively, and insulation is installed and must be done before it is energized. So as far as the reasonably practical and initial inspection should be carried out to verify that all the equipment and materials is in the correct type and compliance with the applicable British standards, and then all types of the fixed insulation are correctly selected and erected. So no part of the fixed insulation is visible, damaged, or otherwise defective, and then the equipment and material used are suitable for the installation to the environmental conditions. Now, the following are the items that cover the inspection. Now, step number 1 is a connection of the conductors. You make sure that every connection between the conductors and the equipment or other conductors must provide durable electrical continuity and adequate mechanical strength. Requirements for the enclosure and accessibility of connections must be considered. Another one is identification of each conductor. You have to identify, provide a schedule of the color, identification of each core of the cable and its conductors. So it should be checked but that each of the core of the cable is identified as necessary. So where it is desired to indicate a phase rotation of the or a different function for cores of same color numbered sleeves are permitted. So the routing of cables, cable routes shall be selected with regard to the cable's sustainability for the environment, i.e. the ambient temperature, heat, water, foreign bodies, corrosion, impact vibration, flora, fauna, radiation, and many others. Another is current carrying capacity. We have to make sure that where practicable, the cable size should be assessed against the protective device based upon the formation of the information provided by installation designer. Another one is verification of polarity. It must be checked. Niko mbio sana. Kasheru. Sawa. I was there, and verification of polarity. Sorry for the speed. Nilikuwa nadhani ni vitu tumepitia, so ni kusoma tu. So where practicable, the cable size should be accessed against the protective device based upon information provided by the installation designer. And then the verification of polarity. We have to make sure that we verify the polarity. That is, it must be checked that no single pole switch or protective device is installed in any neutral conductor, and a check must be made. Must also be made that all the protective devices and switches are connected in the line conductor only, unless the switch is double pole device, and that the center contact of the Edison screw lamp holder are connected on the line conductor. Another thing is accessories and equipment. That is, the correct connection is to be checked. It has to be checked. Another one is selection or erection of the minimize of the spread of fire. That is, a fire barrier or protection against the thermal effect should be provided if necessary to meet the requirements of the BS 7671 standards. The regulation require that each ceiling arrangement is inspected to verify that it conforms with the manufacturer's erection or instruction. This may be impossible without dismantling the system, and it's essential, therefore, that inspection should be carried out at the appropriate stage of the work, and that it's recorded at the time of incorporation and inspection. Another one is protection against direct contact. That is, direct contact as identified by that insulation is an insulation damage or has too much been removed. We have to check that. Then another one is barriers. We have to check barriers where live parts are protected by barriers or enclosures. This should be checked by adequacy and security, having all covers, lids, and plates being securely fitted. Obstacles, we have to check that protection by obstacles provided protection only against an intentional contact. If its method is used, the area shall be accessible only to skilled persons or to instructed persons under supervision. Obstacles can include a fence around a transformer, substation, or a barbed wire fence, or power pylons, or out of reach. Place out of reach protects against the direct contact, that is increased distance, the necessities where bulky conductors are. Now another one is failure protection. Failure protections are defined by this is contact of person or livestock with exposed conductive parts which have become live under fault conditions. So we have to make sure that this one has also been labeled and everybody knows that the protection has also gone down. So an exposed conductor part is a conductive part or equipment which can be touched by but is not live, although it can become live under fault conditions. So example of exposed conductive parts could include metal trunking, metal conduit, or metal casing of electric appliances, e.g. the classroom overhead projector. Earthing provides protection against the type of fault. We also need to check the extraneous conductive parts have been correctly bonded and protective conductors and extraneous conductive parts in the conductive parts that is liable to introduce generally earth potential and no form of part of electrical installation. For example, electronic conductors part are metal sinks, tops, and metal water pipes. The purpose of the bonding is to ensure that all the extraneous conductive parts which are simultaneously accessible are safe potential methods and they are protected. Others is protective devices. Make sure that they have been set correctly for the load, which is reliable fuses have been fitted and has correct size fuses where wire been used, and the socket is provided for outdoor equipment. It has, we have already talked about the RCB having 30 milliamperes, and then check the documents, that is the diagram, the schedule, the charts, the instruction, and any other information that is available if inspection and testing is to be carried out satisfactorily. And then other things, check on warnings and notice. It should be fixed to equipment operating in excessive 250 volts, where the voltage would be normal or expected. So that is what I wanted us to go through. And the process of preparing an inspection is there. These notes, I've already posted them in your portal, and if you don't find them, you tell me to post them. You are going to go through them and look at all those. So today we are done with the